everyone, welcome back to Chem Corner. I hope you are doing well and you are preparing well for the exam. So for the last minute, yes, we can practice with the more MCQ. Today we can do with the 10 MCQ. Let's get started. So the question is, spinach leaves contain three visible dyes, carotene, xanthophyll and chlorophyll. A spinach sample subjected to paper chromatography using a non-polar solvent. And the final chromatogram look like this and solvent front and see the pattern. Which of the following option orders the dyes from the most to least polar? Okay, we need to arrange them in the order of most to least polar. Okay, so what is our principle? Yes, like dissolves like, right? Or polar like polar, non-polar like non-polar, isn't it? So like dissolves like. So what happened? Since the non-polar solvent, so non-polar component will go with the non-polar solvent. So this is the most non-polar. And this one is the most polar substance. So highest polarity is for chlorophyll and then xanthophyll and then carotene. Which option? Among the following, this one is the thing. Correct? Okay. Second question. Some noble gases such as helium, neon are never found as a part of compound. However, other noble gases such as krypton, xenon can be found bonded to other elements in various compounds. Right? We know several compounds like xenon, xenon F4, xenon, several compounds are there. F6, several compounds are there. So why a heavier noble gases will do compounding? Like that the question. Okay. So let's see. First option, noble gas with a smaller radii have lower electronegativity. Isn't it? No. Smaller radii means higher electronegativity. Correct? So that option is wrong. Then noble gas with a smaller radii have smaller ionization energy. Isn't it? No. Smaller radius means very high attraction will be there, right? The positive nucleus and the electron are very much attracted. So definitely a very high ionization energy is needed in order to remove the electron, isn't it? So that option is also very wrong. Then third one, noble gas with the more filled energy levels have empty d shells that can participate in bonding. Okay, that is okay. That is true, right? Then what about the next one? Noble gas with the lower molar mass will experience weaker dissociation, London dispersion force. Lower molar mass have lower London dispersion. That thing is correct, but that is not the best explanation for this scenario, right? So definitely you can go with the option C. Then the next question is they were given a reaction. Okay. The above system is at equilibrium in a sealed container. Some helium gas is added to the container and the container expands. Okay. Maintaining a constant total pressure. So they were maintaining a constant total pressure. So usually the P total is equal to what? That will be PSO2, partial pressure of SO2, partial pressure of O2 and partial pressure of SO3. Now what's the problem? You are added some helium gas, but total pressure remains the same, which means now the same thing with the PSO2 plus PO2 plus PSO, both are SO3, one is SO3, right? Okay, this one is SO3 again, and now partial pressure of helium is also there, isn't it? Now partial pressure of helium is also there, but the total pressure is the same, which means these pressures have like decreased something, isn't it? The pressure decrease. So if you decrease the pressure, they will try to increase the pressure. So system want to do with a increase in pressure. So they will move with a higher number of moles reaction. That can lead a higher pressure, isn't it? So that side, yeah, this side is 2 molar and this side is 3 molar, 3 mole. So definitely they will do with some more forward reaction. Okay, so which option? Partial pressure of all gas must decrease? No. SO2, O2 will increase and SO3 will decrease. That's it, right? Because we already found it is forward reaction. Forward reaction means PSO3 will decrease and PSO2 and O2 will increase. Okay, because as I told you, in order to accommodate this helium pressure, some changes are happened, like something is lowered than the initial one. Okay, right. Then the next one, solutions of NaBr and NH4NO3. So solutions of NaBr and NH4NO3 are mixed, which precipitate will form if any? Okay, let's see, is there any precipitate or not? So what is the formed species? NaNO3, right? This is positive, this is negative, this is positive, this is negative. So the formed species will be NaNO3 and NH4Br. But when you see the net ionic equation, NaNO3, what are the things are like soluble? Soluble list. Yes, group 1 cations are there. Definitely that will be soluble. Group 1 cation. So Na having a group 1 cation, right? Na plus is there. So definitely NaNO3 is soluble. So this is aqueous. Okay. Then what are the other list? Group 1 cations are soluble, NO3 minuses are soluble, and NH4 plus are soluble, like that. So this is that list. You need to study this one. Okay. So here, yes, here also NH4 plus is there. So this one is also soluble. So this one is also aqueous. Then what is the precipitate? Nothing is precipitate, right? So you can go with the D option. Okay. Then the next one. In which of the following Lewis diagram is the sulfur-oxygen bond is longest? Okay. So they were given some SO2, SO3, SO2 with this kind of Lewis structure, and this one SO3 with this kind of Lewis structure. Okay. Bond length is depend upon bond order. What do you mean by bond order? If bond order increases, bond length decreases. Isn't it? The higher the bond order is nothing but how many electrons are shared in between. Isn't it? If double bond is there, the bond order is 2. Single bond is there, bond order is what? 1. Isn't it? Okay, then triple bond means bond order is 3. So if higher number of electrons are shared means higher attraction will be there, bond length will be decreases. So that's the principle. Okay. But this kind of stuff, bond order, there is an equation also there. So you can do it with the equations. What is the equation? The total number of bonds over the number of distributing atoms. Distributing atoms. So what is the thing? Distributing atoms. Right? That is what we called bond order. Okay. This is our bond order. Number of bond over number of distributing atoms. So here SO double bond. So nothing to do with this calculation. You can just simply write 2, 2. And what about the B? B here there is a 2 bond order. Like here double bond is there, here single bond is there. So always that resonance is possible. That's why you can use this equation. Number of bond is 1, 2, 3. Correct? This is 1, this is 2, this is 3. So 3 over, and the distributing atom is oxygen and the oxygen. So 2 oxygen, which means the bond order is 1.5. And here what happening? 1, 2, 3, 4. Isn't it? 1, 2, 3, 4. 4 over 3. 4 over 3 only. So 1.3 I think. Yes. So which is the what they need? Longest bond length. Longest bond length means lowest bond order. So definitely you can go with the D. Okay. Right. The next one. HBRO has a pK of 8.7. A particular view of BRO minus HBRO buffer is shown below. What would be the pH of the buffer solution be? Okay. So this is the diagram, particular diagram. It's a buffer. Buffer means acid will be there, HBRO will be there, and the conjugate base like BRO minus is there. Isn't it? Their ratio is depending the pH. Like their ratio will determine the pH, isn't it? So see how many HBROs are there, because Henderson equation, 1, 2, 3 HBROs are there, and BRO minus 1, 2, 3 again BRO minuses are there, which means the ratio is same. If ratio is same, then pH is nothing but pKa. They were already given the pK as 8.7, so no more calculation. 8.7. Okay. That. Then the next one, reactant A and D combine to form product E via the above reaction. Okay. They were given some reaction and the rate things. Okay. Then, yeah, the question mark. What will be the answer for the question mark? Like this concentration, initial concentration of D is what? If these are the experimental result. Okay. This kind of questions, if you want to solve, first you need to know the rate law. Do they given the rate law? It's not, right? But you can easily calculate by working with this table, correct? Okay, let's do. What about experiment 1 and 2? When you're comparing experiment 1 and 2, this is 1 and this is doubling. At that time, what happening? This one 2 and this one 10 to the power of minus 3 and this one is 10 to the power of minus 4. Okay, so this is quadrupling, right? When D is double, this is quadruple, which means how do you calculate the rate? You know that A raised to something and D raised to something is there. So what is the rate law? Rate is equal to K times this one. Something is there. So our aim is to calculate this M and N. So here what is the thing? D you are doubled and A stays the same. If it's so D you are doubled means for calculating this N, D you are doubling, which means doubling. So 2 raised to N. Okay, if it is tripling, you can write the base 3. If it is quadrupling, then you can write the base 4. Okay, here D is doubling. So 2 is the base and raised to something is there. We do not know. But what happened to the rate? Rate is quadrupling, right? So you can write 2 raised to N is equal to 4. So our N value becomes 2. Similarly, how do you do M? Okay, you need to choose another experiment. Which is the experiment 2 and 3. What about 2 and 3? Oh, 2 and 3 is also not possible because both of them is, it's okay, but making more calculation. You can choose 1 and 3, right? Okay, 1 and 3. See, A is only doubling and the D remain the same. Okay, which means doubling. So 2 raised to, this time M you can write, which is equal to what happened to the rate? Rate is doubling, isn't it? Yes. Yes, 0.5. So doubling. So 2. So which means M is equal to 1. Which means A with respect to 1, B with respect to 2, D with respect to 2. Okay, then how do you calculate the initial concentration? You can again take any equation. You can take the rate law. So now you know the rate law becomes rate is equal to K. You can choose any of the equation. Equation 3 and 4 I'm taking. K A raised to, now you know the concentration. So I'm just taking the exact concentration and rate. Okay. So experiment, according to the experiment 3, what is the rate? 1 times 10 to the power of minus 3 is equal to some K value will be there. And A, you know, 0.2 is there. And B, D, you know, this 0.10 square divided by, and the rate, it's again 1 times 10 to the power of minus 3 K, and this time experiment 4, which means 0.050 is the concentration, and then D concentration we do not know, that is X square. Okay, so this is the thing. This and this cancel out, K can cancel out, then you can solve it for X. So that will be the initial concentration of D in this trial 4. Okay, so you can check the calculation, and I think I got D option. Okay, right. The next question is 10 gram of an unknown metal is heated to 98 degrees Celsius. Okay. Then dropped into styrofoam cup containing 100 ml of water, originally at temperature 13 degrees Celsius. The final temperature of the water stabilizes at 14 degrees Celsius. Okay, so it's increased by 1. Correct? Okay, the first question is, what is the specific capacity of the metal? You know, hot metal system, right? Hot metal, when you are added to a normal water, yes, the temperature from the higher temperature to lower temperature, there will be a heat transfer unless they become a thermal equilibrium, right? So Q metal is equal to Q water. But the thing is, one is gaining the energy, other one losing energy. So one is positive, the other one will be negative. Correct? Okay. So here what is the Q metal? We do not know the specific capacity, but mass is given 10 gram. So what is Q? Q is equal to MC delta T, right? Q metal means metal a mass, and specific capacity we do not know. And the temperature difference, its initial temperature was 98. Now what's the final temperature? Do they given? Final temperature of water is given, right? Is that the same? right? Because the temperature, the heat will transfer unless they attain a thermal equilibrium. So definitely the final temperature of metal is also the same final temperature of water, 14 minus the initial temperature of metal is 18 is equal to negative of Q. Q means here the water mass is 100 ml, so 100 ml and 100 grams, same, isn't it? Because water density is just 1 and the 4.2 is given as a specific capacity of water. And then the temperature difference is, yes, 14 minus 30. So that's all. You can do the problem and yeah, solve it for C. That's all. So I think I got option C. Okay, right. Then the next one. Which of the following is true at thermal equilibrium? Okay, the amount of thermal energy contained in both the metal and water is it identical? The option B, temperature of metal must be same as that of the water. And option C, all energy transfer between the metal and water has stopped. No more energy will be lost to the surrounding. Which one is correct? Definitely option B is the correct one. Because thermal equilibrium means both of them having the same temperature, right? Why is the specific capacity of for the water greater than that of the metal? Because option 1, the sea of electron in a metal cause internal repulsion. Hydrogen bonding present in the water requires a lot of energy to overcome. Covalent OH bond in the metal are stronger than the bonds in the between the metal nuclei, and the metal experience stronger London dispersion force than the water. So definitely this kind of like specific capacity. Why? What is the specific capacity? You know, when you are providing the heat energy, what happening? Their temperature is increasing. So how much energy is needed for raising 1 degree Celsius for a 1 gram substance? Isn't it? That is the specific capacity. Okay, when you are providing heat energy, if they are increased by 1 degree Celsius for 1 gram of energy, 1 gram of compound, then that energy, how much energy you are provided, that is what we call the specific capacity. So higher specific capacity is water means their change in temperature demands more energy. Why change in what is this temperature? Temperature is actually the average kinetic energy, of the molecule, right? So average kinetic energy means they need to move. If easy to move, then temperature will also easy be higher. Okay, so movement, and how it can be moved. Because in these compounds there are so many particles. If they want to move, they want to get rid of this intermolecular attraction. Okay, so higher temperature means higher average kinetic energy, which means there is lower IMF, right? Sorry, higher IMF, right? So we need high IMF, like water have higher specific capacity means water have higher IMF is there. Water IMF is a hydrogen bonding. So which option may be more correct? Definitely option B. Okay, then the last one. If some of the energy lost by the metal is absorbed by the cup, how would that affect the calculated specific heat capacity of the metal? Okay. So the question one, it would be artificially low because the water would not absorb all energy. Okay. Then the B artificially low and C and D artificially high. Okay. So this directionality is very, very important. Okay. Here, what is the problem? You are added the hot metal to this one. But the problem is heat is not fully absorbed by the water. Some heat is absorbed by this cup. Okay. So suppose 100 joules of energy they released. But water gained only 80 joules of energy. The 20 joule is absorbed by this cup. Okay. The calorimeter. So what happened? The water gain only 80 joules of energy. So that the water temperature is only some lower change in temperature, right? Because they got lower energy, correct? So what happened? They got a lower temperature difference. Lower temperature difference making a lower Q water. Okay, which means the Q metal is also we are found like artificially low. It was originally 100 we are expecting, but actually we got only 80 joules. So 80 joules of energy created only that much of temperature change, that much of heat energy. Okay, so that is equal to the Q metal like that we found. So that by using this equation, when you are applying the C specific capacity, yes, this value is artificially low, so that you got an artificially low specific heat capacity. Actually, it was something bigger. Okay, so which option may be more correct? Definitely A option. Okay, so that's it for today's MCQ challenge. I hope you learned something new and had fun solving along. I will be back soon with another video to keep your chemistry strong and sharp. Until then, keep practicing, stay curious, and don't forget to subscribe to Anu's Chem Corner. See you soon.